Hello everyone, this is Dan with Apex Tutoring, and for this question sent to us by Sam, we are looking at another example of the statistics of quality and reliability. So in this question, an intern figures out that a box of defective pieces got into the hopper. There were 250 bad pieces put in out of 1,800 pieces, and there were 1,200 pieces still left when it was discovered. So if each package contained 8 pieces, how many can be expected to contain a defective piece? Okay, so this basically is a drawing without replacement type of problem. And so what we want to think of is here's the hopper, and if I put essentially 1,550 good pieces here and 250 defective pieces, I'm going to randomly draw one at a time and make packages of 8. Now this is going to be tricky because as I take pieces out of this hopper, I'm going to be changing the probability that I pick up a bad piece. So for example, the first bag that I make, let's just say that I want to find the probability of 0 failures or 0 bad pieces. I'm going to have to multiply the probability of getting a good piece the first time, which is 1,550 over 1,800, times the probability of getting a good piece the second time. But since I've gotten rid of a good piece, I only have 1,549, so this is a good one. Okay, now I pick a second piece. So now I only have 1,549, but I have a total of 1,799. And so on and so forth. The next one is 1,548 over 1,798. And we just keep doing that. Okay? And we do that until we get to our 8th piece. And we find out that this probability right here of getting one bag which is not defective, so 8 good pieces like so, this is a probability of 0.3016 if we round that off to 4 sig figs. Okay? Now, what we do is we make basically 600 pieces come out of here, so that equates to 75 bags. Okay? Now by the time 600 pieces come out, there's only 1,200 left in the hopper. So if we want to find the probability that a bag has a defective piece, we could look at the opposite and say, well, what if by some miracle we had 0 defective pieces, and then this would be down to essentially 950. Okay, so the very, very last one that we would do would have a bag that would end with 950 over 1,200. And so I actually did the math. The easiest way to do this is on a little spreadsheet. And so on the spreadsheet, we have basically draw number. We have the number of good parts, or the total number of parts, and the number of good parts. And this is going to be the probability of getting a good part. And then we're going to multiply those together until we get to 8 parts. And then this is, of course, the probability that we have no defective parts. So this is the probability that we have at least one defective part. Okay, so we start with a 70% chance, and 70% of 75 bags would be about 4950 or so, somewhere in that range. But by the end of this, and we're going to have to scroll down a little bit, whoops. By the end of this, when we get to part number 600, now we have an 84% chance of having at least one defective part in that bag. So if we take the average of those two percentages, because it's roughly linear, if you look at this 0.8423, 0.8401, 0.8380, so it's going down by approximately 0.002 2, 2 each time. And that's just an approximate thing. It's close enough for us that we can approximate this as a linear function because there's just so many pieces. So if we were to add those two together, take the average and multiply by 75, we get that there are approximately 58. Okay, so there are about 58 bags that are going to have at least one defective piece. And hopefully this makes sense because we start with a chance of 70% for one defective piece, and then at the end of this process we have above an 80% chance. So it means that we're gonna have quite a few bags that have at least one defective piece. So hopefully this has been helpful to you, and this is a great example of using probability to solve an engineering problem with how many bad bags or defective bags we can expect. So thanks again for sending us your question. Feel free to send any others in the future, and have a great day.